Welcome to GM University Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronic Engineering. So today we are going to study the experiment number 1, that is open circuit and short circuit test on a single phase transformers. So these are the contents, aim of the experiment, theory, apparatus required, circuit diagram, procedure, calculations, and results. So in the aim of the experiment is to predetermine the efficiency and regulations of a transformers by conducting the open circuit and short circuit test in a single phase transformer. So the theory is in this we are conducting a two test, that is open circuit test and short circuit test. In the open circuit test we are determining the core loss and the iron losses of the transformers. In short circuit test we are determining the copper losses. From this we can ultimately determine the efficiency and voltage regulations of the transformers. So these tests are very convenient because this provides the without any actually rolling to the transformers. So further, when we talk about the power is required is very less as compared with the full load output of the transformers. So this test will consist of measuring the input voltage, current, and power to the primary first with the secondary open circuited, then with the secondary short circuited. So this is actually circuit diagram. So in this circuit diagram, you can see there is single phase supply. So this single phase supply is connected to the input of the auto transformer. Then output of the auto transformer should be connected to the input of the multifunctioning meter. Then output of the multifunctioning meter should be connected to the primary side of the transformers. Then secondary side of the transformer should be left open. So this circuit indicates it is an open circuit test. So in this test we are determining the iron losses, or you can say the core losses. Then we can determine the parameters such as R0 and X0 of the transformers. So in this test the rated voltage is applied to the primary, that is we have to apply the very low voltage while the secondary should be left open. So this is circuit diagram for the short circuit test. In the short circuit test we can see the single phase supply is connected to the input of the auto transformer, that is single phase auto transformer. Output of the auto transformer is connected to the multifunctioning meter, that is input of the multifunctioning meter. Then output of the multifunctioning meter is connected to the primary side of the single phase transformers. Then secondary side of the transformer should be connected to the, you have to make the short circuit on the secondary side. So this is the procedure. In the open circuit test we have to make the connections for the given circuit diagram, then close the switch where is the auto transformer, adjust to the rated voltage of the transformers from the auto transformers. Then take down the readings of ammeter, voltmeter, and wattmeters. Then we have to bring back the auto transformer to the back to the zero voltage. Then switches should be kept open. So this is the procedure for the short circuit test. We have to make the connections for the given circuit diagram. Then supply switch should be closed where is the auto transformer. Adjust the voltage to the rated current of the transformer. That is, we have to calculate the I rated. So I rated is given by kVA rating divided by voltage ratings. That is, if it is a 2 kVA, then you have to take the 2 kVA divided by 230 voltages. Then it comes to be around 8.6 ampere. So that much of voltage, that much of current should be provided to the transformer during the short circuit conditions. Next, then we have to take the readings of ammeter, voltmeter, and wattmeter should be noted down. Then bring back the auto transformer voltage to the zero. Then the supply switch is kept open. And these are the formulas. We can find out the that is iron losses, that is power factor, that is W0 divided by I1 into I0. So IW is a working component, that is I0 into cos phi 0. Im is equal to I0 into sin phi 0. R0 is equal to V1 divided by IW, and X0 is equal to V1 by Im. So these are the formulas to find out the Z01, that is the impedance which is referred to the primary side, VSC, that is short circuit voltage divided by I1. For the leakage reactance on the primary side, that is X01 is equal to under the square root of Z01 square minus R01 square. For the short circuit power, PC divided by VSC into I1. So these are summaries to find out the open circuit test. We have to find out, determine the power factor. Cos phi 0 is equal to W0 divided by I1 into I0. So IW is equal to I0 into cos phi 0, Im is equal to I0 into sin phi 0, R0 is equal to V1 divided by IW, and X0 is equal to V1 by Im. Only for the short circuit test, we have to determine the Z01, X01, and cos phi 2. Thank you.
Welcome to GM University Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 1, that is open circuit and short circuit test on a single phase transformer. So in this test we are going to determine the predeterminations of the efficiency and regulations of the single phase transformers. So this is the circuit diagram connections. So output of the transformers, right? This is the transformer. Output of the transformer should be connected to the input of the multifunctioning meter. Then output of the multifunctioning meter should be connected to the primary side of the transformers. Then secondary should be kept left open. That is S2 and S1 and S2 should be kept open. Now we have to vary the voltage from the auto transformer till we get the rated voltage of the transformer, that is 230 voltages. So once we get the 230 voltages, we have to check in the multifunctioning meter. So 230 voltage is the rated voltage, current is 0.29 and W is 0.26. Now we have to take the readings for the short circuit test. So that is 230 voltage is the open circuit voltage, open circuit current is 0.21 and WC is 0.25. Now we have to vary the auto transformer. We have to bring back the auto transformer to the original position, that is back to the 0 voltages. Then we have to close the switch. Now we have to, for conducting the short circuit test, we have to make the secondary side as shorted. That is the, for the 2 kV rating of the transformer, we have to make the short circuit. That is S1 and S2 should be short circuited. You can see this is the now secondary side is short circuited. So now we are going to conduct the short circuit test. Now vary the auto transformer until we get the short circuit current, that is 8.6. So we have to calculate the short circuit current for the 2 kV ratings. As I told, it is 8.6 ampere. That is 7.3, 7.4, 7.8, 8.1, 8.3, 8.4, 8.5, so 8.6, 8.7, 8.6. Approximately keep the 8.6 ampere. Now to calculate the 2 kV rating of the transformer, that is, we have to calculate the 2 kV rating of the transformer. We have to find out the I rated, that is 2 kV divided by 230 voltages. So current will be around 8.6 ampere. So this much of current can be given to the short circuit conditions of the transformers. Now we have to take the readings. So what is the voltage now? 16.1. So 16.1, 8.62, 8.62. What is the WSC? 0.128. Now again you have to vary the voltage, bring back the auto transformer voltage back to the 0. Then off the switch. Thank you so much.